Hello and welcome to Eco Show. I'm Henry and I study ecology. This show is about ecology research, happenings, and good news. I usually talk about an animal of the week and then go into some research from a recent journal, and then I wrap it up with some good news. And this week I recorded this episode, and when I went to put it together, I found that I had not recorded any sound with it. So I'm re-recording the episode. If I seem a little low energy or unexcited by things that I'm saying, it's because I did this a little bit earlier today, but that won't hold us back. And so it's with a lot of excitement that I announce the animal of this week is the earthworm. It's a terrestrial invertebrate that we all know and we love. And terrestrial just means earth-bound or on land. And invertebrate means it has no spine. Okay? It's in the Annelida phylum, and in the first time I recorded this, I tried to describe what phylum was, and I didn't do a great job, and I haven't looked it up since. So I'll continue to describe phylum poorly, which is kind of a big level classification. Just like how you can think, I tried to do this analogy before, there's house cats, and then there's like lions and cats and things like that. But that's not I don't think there's a phylum for cats, but I don't know. Anyways, they're a part of the Annelida phylum, which is just segmented worms. It includes leeches, and there are 22,000 species in this phylum. So that's pretty cool. Okay. These worms eat organic matter, and that includes... I gotta pull it together. Okay. Okay, earthworms. I'm putting my hand up to indicate when I want an image of a worm. And I'm just thinking now, because I'm doing it night. Usually I do this during the day, so it wouldn't be easier for people to see me doing this, but now I have a big window and the window's open, so the city can see me recording this. Anyways, earthworm, is the animal of the week for us. They eat organic matter, and they eat plant matter, bacteria, and fungi. Their digestive system runs the whole body. And I was thinking earlier and saying out loud that it would be interesting if we had digestive systems running our whole bodies, and it might be more convenient to be able to do your business out your feet, but it would be gross. And they breathe through their skin. They have a nervous system with motor and sensory neurons in each segment of their body. And they have a bilobed brain, which means they have two sort of little bits that are the main neuron centers that are in their head, and it goes off in sort of two, bi meaning two, and lobe meaning lobe, like earlobe. Okay, and they have chemoreceptors in their mouth, so they can taste sort of as they go. And they have fluid-filled chambers for their structure. So since they don't have a spine, they rely on fluid pressure in their body for their body structure. And very interesting. I didn't know this before. Earthworms are hermaphrodites. And so in mating, two will exchange sperm and fertilize each other's eggs. So that's pretty cool. And the first time I recorded this, I was genuinely I forgot that I had written that down about them, and I was surprised again. Now I'm not surprised, but I hope you're experiencing some genuine surprise from that, because who thinks, I don't look at a worm and think, I never thought that about a worm before. That just shows me for making that assumption about worms. I don't know what I assumed they would have been. There are different species of earthworm, and these different species can range from 10 millimeters in length to 3 meters in length. So that's from about smaller than the size of a fingernail to the height of a basketball hoop. And the belt-like part, I can say it with a straight face. The first time I couldn't say it with a straight face. The belt-like part of an earthworm, and I'll keep the image up here, so I'm putting my hand up. Henry put an image here. The belt-like part on an earthworm is called the clitellum, and it produces egg capsules. So now you know what that's about. They have no eyes, but they do have photosensitive cells, which means cells that are sensitive to light. And they can live 4 to 8 years in the wild and 1 to 2 years in a garden. So that might be because, well, we'll get to it in a moment, I guess. They move by contraction and can push 10 times their body weight. So they really got to push things out of the way to be able to move through soil. And there are 3 main types, sort of categorized by how their lifestyle. And the first type lives in sort of the leaf litter, the upper areas above the soil. The second type lives below that in the soil and has horizontal burrows. And the last type lives deeper in the soil and has vertical burrows. And so you can just imagine these different sort of burrowing styles would allow for air to circulate and get into deep and varied areas of the soil, and aeration in soil is important for different minerals like nitrogen to be able to be used by plants. But unfortunately, when nitrogen and fertilizers are added to soil, it can create acidic conditions which are deadly for earthworms. And fertilizer has reduced many populations. I've said that about aerating and mixing the soil. Yeah, and they mix the soil, so distributing nutrients around in the soil. Their poop is is broken down organic matter, so that is helpful for soil health, other beings in the soil, and plant roots in the soil. And yeah, their digestion makes organic matter usable for plants. And they may vary from 250,000 to 1 million per hectare of soil. That's number of individuals. And a hectare is 100 meters by 100 meters. So it's kind of like the size of a wide football field. So that's a lot of worms. But that's a lot of area, so worms making good use of that. And in many places around the world, they are eaten. They are consumed for food by people, and they're used for bait. They're also consumed by birds, which we've probably seen. Early bird gets the worm. In this case, early bird, which I guess, so why does the early bird get the worm? Why are the worms out early? Maybe it has to do with their photosensitive cells. Maybe when it's dark, they're confused about where the surface is. So maybe in the dark, they just end up closer around the surface. Or not. Okay, so that's the earthworm, which is the animal of the week. I was pretty animated while I was reading this the first time, but you'll have to wait for next week when I'm more animated again. Okay. And I'm going to just check. I had a switch that was slightly in the wrong place, and that's what I believe messed it up. So I'm hoping that has not happened again. I have a new type of mic that I'll be rolling out next week that's just a little bit more aesthetic. So you can look forward to that. And hopefully the mistake won't happen again. Okay, this week the journal that I was looking at was Nature Sustainability, and that is a subspecies of journal from the sort of big journal called Nature. So Nature has there's Nature, the journal, and Nature also makes lots of smaller journals. This one is called Sustainability. Pretty straightforward. It is about different advances in sustainability on wide-ranging topics, as we will see. And this is all from one journal, the most recent one, I believe. So the first article that we're looking at is by Shilai Zhang et al. I'm not going to read the title because the title says everything about the paper. And that is often the case, so I usually don't read the title until the end. Okay, so the problem that they're looking at in this is that there's a need globally for agricultural systems to intensify with a global population. That's what they say in the paper, but there's a lot of food waste. So I think if we made better do with food waste, we could probably make do pretty well with what we've got. But anyways, there's demand to intensify sustainably with better yields, better farmer livelihood, better soil health, and using fewer resources. So really, there's a need to have your cake and eat it too in regards to agricultural production. And a possible way to have your cake and eat it too is switching annual crops to perennial crops. And that just means annual crops are every year, even though, so you take a seed, you grow it into a seedling, and then you plant it. And then at the end of the year it's dead, and then you have to do that over and over again. Annual is a little bit misleading in agricultural systems because oftentimes, like we'll see in this paper, some plants are having to be replaced every season. So it could be multiple times a year. And perennial plants are plants that live for multiple years. So they are saying that a possible solution to those problems laid out is switching annual crops to perennials. And in particular, they're looking at switching an annual rice for perennial rice. And the way that they did that was by hybridizing Asian rice, and that's what they called it. They called it that in their paper. And they hybridized that with an African rice. And the African rice was perennial, and the Asian rice was annual. So having your cake and eating it too. And currently, annual crops span 60 to 80% of cropland, and they are 80% of the food source. So they really dominate our food system, and that is a big opportunity for situations like this, possibly switching over to perennials. So they wanted to see how this perennial hybrid rice stood up against an annual rice, and they found that the perennial rice produced just as much, if not a little bit more, than annual rice species over a period of 4 years. And annual rice needed replanting, new seed, and labor every season, but often anyways. And this annual rice led to more soil carbon. This annual rice also saved 50% of time on labor and 49% of input costs. So not having to go out and replant things saves a lot of resources and a lot of time. And it was preferred by farmers when they interviewed them because it was a lot easier and a lot cheaper. And we all know how lazy farmers are. I made that joke the first time, and it still is not a really good joke, but I'm joking that farmers are lazy, but I don't think farmers are lazy. So there you go. You still got the bad joke. Wow. Okay. And I think I'm possibly going longer than the first time. Anyhow, so this was pretty successful. And my thought was, I wonder how it tastes, because they didn't talk about that. I wonder if the annual rice possibly tastes better. But then my counter thought to that is that I think if I knew I was having perennial rice and farmers were more relaxed and chilled out, that I think that would taste aesthetically better in some ways. But so I think even if it was that much of a difference in taste, I don't think I would really mind. But I don't really eat that much rice, so there you have it. Okay, so that's our first research paper, and that was titled Sustained Productivity and Agronomic Potential of Perennial Rice by Shilai Zhang et al. Our second article is by Brett Sanders et al. And the problem that they're looking at is related to flooding, which we've seen globally from Pakistan to Aotearoa, New Zealand, to the U.S. recently. Usually in the U.S., flooding is sort of thought of as happening with these storms that come through the eastern U.S. But as we saw recently with this atmospheric river, the western U.S. can get really inundated as well. And they point out in this article that in 1861, there was a massive flooding event that led to 1/3 of taxable property being destroyed. So that was a massive flood. And I'll put my hand up right now to put in an image, possibly of the flood. And it was really a big deal. This was a 1 in 500 year flood that happened in 1861. And for this paper, they are exploring the impacts of, or modeling the impacts of a 1 in 100 year flood on Los Angeles. And what they're looking at in particular is the impact of this modeled flooding event on people from different areas and different incomes and groups, because flooding tends to impact poor and marginalized people significantly more. And when they are affected, they also end up getting less help afterwards. So they want to see what that relationship looked like in Los Angeles, which experienced massive flooding back in the 1860s, and as we've seen with these atmospheric rivers, has the potential to be affected now. I feel like my hair is going to fly away, so I'm pushing it back. And they found that in Los Angeles, when they model a large flooding event, that particularly areas where African American people live, and to some extent where there are populations primarily of Latino people, that they will get the most affected. So where there is the worst infrastructure to deal with a massive flooding event, which could happen in Los Angeles, is particularly where most African American people live in the city. Coincidence? Probably not. But they're pointing that out in this. And put my hand up for the other thing, for another thing from this, which was flooding areas for a hypothetical flooding event in California. And the major areas that we see getting flooded in here is in the Central Valley, which is a big agricultural area. And so you can imagine that area getting flooded. That would be a big impact on people's livelihoods and things like that. But it could also really be a big deal in Los Angeles. So the sort of call to action that they were giving from this is that this sort of study should be undertaken in other cities around to see where are most at risk for flooding. And they're really calling for a better response to flooding, doing a better job with that. And that article was, so that was sort of more of a conceptual article, but they're saying, hey, look at this is a big issue. It's going to really impact people. And their method can be easily replicated in different areas as long as there's some data on flood risks and population composition. So the title of that was Large and Inequitable Flood Risks in Los Angeles, California. Okay, moving right along. Our next article is by Gaofeng Wang et al. And the problem that they're looking at is that rare earth metals are used for many things, but extracting them causes environmental damage. So rare earth metals are used in phones and electronics, and they are sort of a very sought after resource that limits development of electronics. So the other components that go into electronics are easier to get than these are, so they sort of limit how much you can make. But extracting them causes a lot of environmental damage because the most common techniques involve pumping solutions down into the ground where these are, or doing some sort of, so you pump these fluids into the ground to this layer in geology in the soil basically, but it's below the soil, to where these rare earth metals are. You pump this fluid that sort of picks them up and carries them out, and then they can collect them and sort them at the end. That's kind of a bad way of describing it, but that's more or less what's done now. But this fluid that they're pumping in and under the ground is super toxic. It gets into water systems. It kills off forests. It's really bad. And the places where these are mined are mostly in China, and China supports 95% of the global demand. So typically when there's a resource that's as valuable as something like rare earth metals, people are pretty willing to tear up the ground and cause whatever damage is necessary to get at these things. But this is the destruction is so bad that it's become limited. They've actually had to crack down and limit the practice. And that's not something that you're used to usually seeing. Especially when, I'll just say it's usually not something you're used to seeing, but it's really is that bad that they're just like, okay, we have to limit it. And a possible solution to do this more sustainably is by this new method using electrokinetics rather than flushing, and it also reduces processing at the other end. And essentially what this does is it still uses a fluid, but instead of pushing the fluid through to flush these out, it sort of, I guess, inserts a fluid, and then it's not a magnet, but you can almost imagine like a fluid is put into the area underground where you need these things, and then you have like a magnet that then attracts these rare earth elements out from that area. So those are both rough and probably sort of inaccurate ways of describing what's going on, but that method, as you can imagine, because they're not pushing fluids and flushing things through, there's less spread, it seems like, and wider pollution of the area. It still sounded like it was not great, but I believe they said it was 80% more. It may have just been 80% more efficient, but it is supposedly somewhat better. And the title of this paper was "A Green and Efficient Technology to Recover Rare Earth Elements from Weathering Crusts." And the idea that I got was really that it should be called "A Greener and a More Efficient Technology to Recover Rare Earth Elements from Weathering Crusts." And weathering crust is just the name for the geological layer underground where these rare earth elements tend to accumulate. And so this is a new method to extract those rare earth elements from that area for our phones and electronics. So, yeah, good to keep in mind. You know, if you can use your electronics for a little bit more, do it. Okay, so that's kind of this one. I'm going to put up an image here that shows how they're describing it. And so describing the electrokinetic thing that's going on. So you can see on one end there's sort of a battery-like thing on two ends. So and then you have a sort of fluid area, which is this sort of blue line where I believe the elements are going out through. Okay. And our last research article, and yeah, I read the title for that one. The last research article is by Peng Peng and Arman Shehabi. Peng Peng or Peng Peng, not quite sure. And the problem that they're looking at is that globally, but particularly in the US, waste electronics are a big issue. And so waste electronics, just meaning the electronic things that are thrown away, they're a big problem because they are super toxic, and they're often recycled overseas by sending them to poor countries that end up just either putting them in landfills or having them in the environment, and they're super toxic to the environment and to people. And there's just an increasing amount of electronic waste being produced as we get more electronics in our homes and our vehicles and everything. And so they're exploring this issue of electronic waste and how we might go about fixing that issue. So let's see. Only in the US, only 17% of electronics are recycled properly. So that is a huge amount of electronic waste that is going where it shouldn't be going. And like I said, a lot of this is exported to developing nations. And the solutions that they talk about, and again, this is another overarching look, is that there are already places that process minerals. And so I'll go back to say that in these electronics, the components that tend to make them up are rare earths, like we talked about in the last paper, gold, copper, and plastic. And so those all can be used and reused in various different ways. And what they are pointing out in describing this article is that by recycling these things, you can actually make a lot of money from that. So it's worth it economically to recycle these things because of all the valuable materials. In particular, they point out that the gold used in these electronics, if recycled correctly, could amount to the amount of new gold that's extracted in the US. And places that extract gold currently could be used to recycle and extract this gold from these electronics. They point out that areas in the East Coast where you don't have as many mines are lacking in recycling facilities, so they should be putting in recycling facilities in those areas. So just sort of an overarching paper looking at this and describing the issue that is electronics and pointing out that there are some possible solutions to that issue because it can be economically beneficial. And so the title of this was Regional Economic Potential for Recycling Consumer Waste Electronics in the United States. And so they sort of talk about different areas that should have new recycling facilities or could use current facilities. So they sort of look over the US for this potential to recycle electronic waste. Okay, and good news, so I'm going to the good news section now, but it was kind of nice reading this sustainability paper because a bit of it is sort of things that I wouldn't usually run into. But, not great news, but it's positive to see the directions that things are moving in. They're in a beneficial way, even though the emphasis is often economically related rather than ecological or social. So that would be great to see in our sort of lifetimes for things to shift in a way that's valuing the environment and people more highly and more on par with the economic side of things. But things are sort of slowly moving that way, so it seems. Anyways, on to the good news. There was a Przewalski horse born in the San Diego Zoo, and I'm sure that's an incorrect way of pronouncing the name of that horse, but that horse is a rare native wild horse to Central Asia, and it was extinct in the wild and has been regenerated, I think, just through zoos and things, basically. And the last wild horse, this is just sort of background on these horses. So it's the last species of wild horse that's still around, and it's separated between 30 and 100,000 years ago from common domestic horses. So I'm not sure how many are born each year, but at least one was born this year, and that is probably adorable. So here's a hand up for where I will put an image of the horse. And if you're just listening, it's sort of a brown, it looks like a horse. It looks kind of maybe like a brown donkey. I hope that's not offensive to donkeys or Przewalski horses. I'm sure they have opinions on being classified as one another, so I'm not trying to offend all the donkeys or Przewalski horses out there. Go you, go Przewalski horses. You're doing a great job. Keep it up. Okay, and our last, well, the other good news thing for today is that there was no rhino poaching reported last year in Assam, which is a region in India, and the population of rhinos in Assam has gone from 119 in 1910 to 3,000 today. So they're making a pretty good comeback, it looks like. I didn't even realize there were rhinos in Assam. Here will be an image of a rhino that is hopefully from Assam. But it's good to see that they're making a comeback. And the way that they did this was by working with people in these rhino areas and incentivizing them to report people who were poaching rhinos, I believe. So they worked on the ground and were paying people, helping people out to conserve these. So, yeah, good news on the rhinos. I'm going to find out now if I've messed up the audio again. Hopefully I have not. And I will see you all next time. Hope you're having a great week. Bye.